Video solutions for the Unit 2 Roots and Radicals homework packet 21 through 28 for October 2nd, 2013. Now, I'm not going to do all the problems. If you're watching this video, watch it all the way through, and you only have to do the problems that I'm doing. You don't have to do all the rest. And I'll know that you watched the video if you did just those problems. So the first thing we talked about today is determining if a number is rational or irrational. So we have our rational numbers here are fractions, decimals, repeating decimals, percents, integers, and the square roots of perfect squares. Our irrational numbers are the square roots of non-perfect squares, and we have pi, that's a common irrational number, and then any number that goes on forever and never ever repeats. So if I go through this, I'm going to go through it quickly because we did do it in class today. Okay, this is the square root of 3.5. That's not a perfect square, so that's not rational. Square root of 6, not a perfect square, not rational. Okay, pi, again, not rational or irrational. Okay, d, 1/3 is rational. It can be a fraction. E, square root of 10, irrational because that's not a perfect square. F, okay, this negative we know follows along from a previous lesson, and I have the square root of 49, I can do that. Negative 7 then, I can make into negative 7 over 1, and we know our definition can be written as a ratio, which is a fraction. Okay, square root of 108, again, not a perfect square. Okay, 0.25, that's a decimal. I can change 0.25 into 25 hundredths, which is a fraction, so I know it's rational. 2/15, rational. Okay, we know that every repeating number or decimal is a rational number because I can change that to a fraction. When everything repeats in the decimals, I simply take that number that repeats and put it over the number of nines that would match the number of repeating decimals. So there's one number that repeats, so 1 9. Over here, 0.36 with the 36 repeating, 2 nines. Here, 0.403 with the 403 repeating, 3 nines. Okay, I'm going to go ahead and skip 22 because we already did that. Oh, J is, got to go back there and circle that. 22, we did that in class. Okay, so then I'm not going to go through all the notes. We worked on this in class. So I'll just explain it as I do it. So let's go down to 24. Okay, I know x to the 7th isn't a perfect square because it has an odd exponent. I need even exponents, so I'm going to break that up. So we're talking about jail here. Okay, I need to separate the people that are in jail into the perfect people and the non-perfect people. Well, we learned in class that if we simply take away 1 from the odd exponent, that's going to leave us an even number. So I had x to the 6th, and then there would just be the x. This is a perfect square because what times itself is x to the 6th? X to the 3rd. To check it, x to the 3rd times x to the 3rd would give me x, and 3 and 3 would give me 6. So the square root of x to the 6th is x to the 3rd. That person gets out of jail. This guy, he's by himself. He has to stay in jail. So your answer is x to the 3rd times the square root of x. Okay, let's go over to C. Square root of x squared. Well, this already has a even exponent. So it is a perfect square. This guy doesn't belong in jail. So the square root of x to the squared is x, because x times x gives you x squared. Notice there's nobody in jail there. Okay, go to E. Square root of x to the 8th. Well, again, the 8 is even, so I know this is a perfect square. So I can find the square root of it. I just cut the exponent in half. Simple. Most of you had no problem with this today, and it was a great day for that. Okay, G, x to the 3rd. Well, that is an odd exponent. So I'm going to need to separate it into x squared, so I take 1 away, times the x. Now this is a perfect square because it has an even exponent. So the square root of x squared is x, so I pull this guy out of jail, kind of technically like that. This guy has to stay in there because there's nothing times itself that's x. Okay? Now, if we can do that with variables, we can do that with numbers. So here, instead of using the variables, I'm going to use those first 20 perfect squares that I keep harping on you to remember. So square root of 50, that's not a perfect square. I need to separate it into a perfect square and another number. So does 4 go into 50? No. Does 9 go into 50? No. Does 16 go into 50? No. Does 25 go into 50? Yes. 25 is a perfect square, so it's 25 times 2. 50 equals 25 times 2. Just happens to be square root. Now, I can go ahead and separate them just like I did on the other side. So I'm actually putting these guys in different jail cells. Now, what's the square root of 25? 5. I can't find the square root of 2, so that guy just stays in jail. Okay, this guy's at the door, you know, nah. Okay, let's go down to C. Square root of 20. Well, that's not a perfect square, so I'm going to have to separate it into 4 times 5, because 4 is a perfect square. Now, I'm going to skip this step right here, because we can do that in our head. So I have the square root of 4, which we know is 2, and then the square root of 5 can't be done, so that guy stays in jail. Okay, E. Square root of 75. What perfect square is within 75? 25 does. So that would be 25 times 3. All right, so now find the square root of 25, which is 5. That guy got out of jail. Boink. And then I still have this other guy in there, square root of 3, because he's not perfect. Okay. Let's jump down here and go to I. 63. Well, 63 would be the square root of 9. 9 times 7. So the square root of 9 is 3. That guy gets out of jail, and the square root of 7 has to stay there. Now, what happens when we have a number in front? Well, it's kind of like this. Just pretend that this guy right here is just along to visit. So he's separate. He just stays there. I have the square root of 18, so let's just work with that. Square root of 18 would be, let me see, 4 doesn't work, 9 does, so 9 times 2. Okay, this guy is just coming along, so just bring him along after that. Okay, we know it means multiplication when a number is in front of a symbol. So that's why I use this multiplication. Now, this problem right here is just like all the rest of these then. Okay, so ignore the 11. So the square root of 9 is 3. I can pull that out. The square root of 2 stays in jail. Now, since it's simplifying, I can actually do that multiplication. So that's 33, and then I have the square root of 2. Okay. All right, so let's do just a couple of these. How about 150? Well, let me see. 4 doesn't go in there. 9, 16, 25 does. I think that's it. So that would be 25 times 6. I know the square root of 25 is 5, so I can pull that out. The square root of 6 has to stay there because it's not a perfect square. Okay, 500. Now, square root of 500 can be divided into 25 times 20. However, if I go ahead and do that, I'm forgetting that 20 can be divided up into 4 times 5, and 4 is another perfect square. So my job when I'm factoring radicals is to try to come up with the biggest perfect square. So go through your whole list. So after 25, I should have said 49 doesn't work, 64 doesn't work, 81, 100, and it would have come to me. So that's 100 times 5. Okay, I know the square root of 100 is 10. So that guy's out of jail. The square root of 5 has to stay there. Okay, let's do 147. Okay, so let me see. 4 doesn't work because that's an odd number. 9 doesn't work. 16, no even number goes into an odd number, and this is odd. 25 doesn't work because it doesn't end in a 0 or 5. 36, that's even. 49. How about 49 times 3? Let's check. 27, 2, 147. There you go. So 49 times 3. So the square root of 49 is 7, and the square root of 3 would have to stay there. Okay, let's do one of these down here. Let's do 40, I, or L, I guess. So we know that 40 comes along. He's just waiting for his buddy to get out. Square root of 27 would be 9 times 3. Okay, so 40 again comes along. And we know that's going to be multiplied by the square root of 9 because this guy's getting out. So the square root of 9 is 3. This 3 right here, the square root of 3 has to stay in there. That's why in all these problems, I always put the perfect square first. every single one of them, even back to these. I always put the perfect square first. So that'll help you keep track of your answer in the end. Okay, so then I have my 40 times my 3, which is 120, and I still have that guy in jail. All right. Now these look hard, but all they are is simply a number and variables that I can separate and do all separate. In other words, I don't do this all at once. So I could have done this. So this is square root of 18 times the square root of x to the 5th times the square root of y to the 4th times the square root of z squared. Now, this problem right here, square root of 18, looks like these right there. And the square root of these letters looks like these. I'm just doing them all in one problem. So let's start with the square root of 18. So that's the square root of 9 times 2. Again, 9's perfect square, so the square root of 9 is 3. And then this square root of 2 has to stay there. So that one's done. Okay, x to the 5th. Well, 5 is odd, so it's not a perfect square. So remember what we did? We took 1 away to make it x to the 4th times x. Now, the square root of x to the 4th is x squared, and then this x still has to stay in jail, doesn't it? Okay, y to the 4th is a perfect square. It's got a 4 there. So right off the bat, y to the 4th is y squared. Okay, z squared is a perfect square, so the square root is just z. Now, to put the answer together, everybody who's out of jail is going to leave together. So the 3 is out of jail, the x squared is out of jail, the y squared is out of jail, and the z is out of jail. Who's left in jail? This 2 and this x. So there's your answer. Okay, let's go down and do D. So I'm going to separate them. Square root of 49 times the square root of x to the 6th times the square root of y to the 9th times the square root of z to the 9th. Well, square root of 49, guess what? That's a perfect square, so that's easy. That's 7. Okay, square root of x to the 6th, this is a perfect square, so the square root is x to the 3rd. Y to the 9th is not a perfect square because the exponent is odd, so we need to separate that into x to the 8th times x. And now the square root of x to the 8th is x to the 4th, and then this x has to stay in jail. Z to the 9th, same as y to the 9th. So if I wanted to, I could just come down here and do a shortcut. It's just going to be a different letter. So x to the 4th, square root of x, so this would be z to the 4th, square root of z. It's same problem, just different letters. All right, so who got out of jail? 7, x to the 3rd, x to the 4th. Whoops, oh, I made a mistake here. Those are y's. Bet somebody caught me. So those should be y's here. Okay, got to pay attention to the letters. So this would be a y there. All right, and then z to the 4th. Okay, who's still in jail? This y and that z. Okay? All right, let's do one more. Let's do G. So I have the square root of 56 times the square root of x to the 5th times the square root of y to the 2nd times the square root of z to the 8th. All right, 56 is not a perfect square, so let's divide it up into, let me see, 1, 4 goes in there. 9 doesn't, 16 doesn't, 25 is too big, so that's going to be 4 times, looks like 14. So the square root of 4 is 2, and the square root of 14 can't be changed, so it stays in jail. X to the 5th, we know that's an odd exponent, so we have to separate it into x to the 4th and x. The square root of x to the 4th is x squared, and then this x has to stay in jail. Okay, y squared, we know the square root is just y, so I can bring that down. Z to the 8th, we know the square root is z to the 4th. So, who's out of jail? The 2, the x squared, the y, z to the 4th. Who's in jail still? The 14 and the x. Okay? So, that's all that you have to do. You don't even have to do number 28. So altogether that was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 problems. And then we did these 16, so basically 17 altogether. All right, good luck, and if you need help, come in and get help, or watch the video again, or call a friend, whatever you need to do. Okay, let's start taking care of those retake quizzes. If you do a retake quiz, remember to bring in your work and show me so I can give you your score.